have slides this time because I wanted to go faster than the last one did. But the first thing we'll do is to recreate the project so we can continue from where we started off the last time. So we start by going to the command line. If you have it ready, just keep it open and continue from there. And then we use yeoman to scaffold the project using the yo command. So if you don't remember what scaffolding is, it's like if you were using an IDE and you did file, new project, and you selected the type of project, and it created all the necessary files. That's the same thing that yeoman does. In this case, we're using it to scaffold an ASP.NET project. I'm just recreating what we did last time, but I'll go really fast and then we'll continue with the new stuff.
I was predicting that one person would show up.
This is taking forever. Things always misbehave when you're recording them. So we picked the web application basic template without membership and authorization. And then we're using Bootstrap for the UI framework, and I'm going to call the project backend. So it creates all the necessary files, and then it uses bar to install the front end files like Bootstrap, jQuery, and all the other necessary things. Yeah. I was on Linux just before this and it was all fast. Now I switched back. And everything is slow. And my time is clearly wrong. Okay, so it's still going. Alright, so we're going to change directory to the one we just created. And then I'm going to use the .NET restore command to restore all the C# packages that we need for the project to build. So once it's done building, I'm going to open it in Visual Studio Code. If you have Visual Studio Code on your path, you can open it directly from the command line using that command, or you can open it directly from Visual Studio if you navigate to that folder. So I'm going to use Visual Studio Code. So in the API we're building, we had just one item in our model, items, and each item had a price, an ID, a title, and a description. So that was the first step, to add a folder to store our models, and then inside that we add a class for items. And then I'm just going to go ahead and paste the previous stuff. So we use data annotations to they're going to come up later once we start validating items. So in this case, ID is the key. We use that to tell different items apart. And then each item has a title, minimum length 1, maximum length of 100. The description has a max length of 300, minimum length of 1, and the price is of type currency, and all three of them are required. So that means, for instance, if you try to create a new item and one of those is missing, then it's not going to work. Same thing goes for if you try to update an item. So once you have our model, the next thing we did was to modify the project file to include entity framework.
How do you create a folder in your
In the root,
yeah.
if you click an empty space, for instance, right below, and then click the button at the top to create a new folder, or you can right click, it creates a new one. If it doesn't create it in the root, you could just drag it to the root.
Well, it creates it in the root. It's creating it in like www root only.
Drag it out of that if you can. Now it needs to be at the same level as www root. Okay. So the next thing we did was to add entity framework. That's the framework we're going to use for interacting with the database. It provides several classes that support, in this case we're using SQLite, and it makes it easy to interact with the database without us having to do a lot of work. So the next thing we're going to do is go to backend.cs project. This is where you include all the necessary packages your project is going to be using, and then I'm going to add the entity framework SQLite reference. So once you change one of these references, you need to do another restore. So I'm going to close this, go back to the command line, and do .NET restore again. So now it should download the new package we just added to that file.
what's the file you created in models?
Item.cs. You can look on the GitHub page. The complete project is on there. That way you can copy and paste along if you want to follow. So once the new package is downloaded, we're going to reopen the project. And then we're going to add the necessary classes to interact with the database. So we're going to create a data folder in the same level that we created the models folder. So I'm going to add a data folder. And then the first thing we want to add to this is the context class. So I had mentioned the context class is like the gateway to the database. Whenever you interact with the properties defined in that class, you're directly interacting with your database. So inside this, I'm going to call it app db context.cs. So the context class defines just a single property. In our database, we want to have a table to store all the different items. For any table you want to add to the database, you have to add a property for that in this class. And that property has to be of type dbSet. And the type of the item goes between the angled brackets.
Are you just copy pasting all of that?
Yeah, so this is what we did the last time. That's why I'm going really fast, so that we can continue with the new stuff. So this is the context class. If you do get this prompt, be sure to click yes. This way you don't have to use the command line to run it each time. You can run it directly from Visual Studio Code. It downloads the necessary files for that. So once you add the context class, the next thing we want to do, so to make sure everything is working, we're going to add a class to initialize the database. So once the project starts, we need to make sure if the database is not there, we want to actually create it. If it's created and initialized, then we don't need to do anything. So I'm going to add another file to the data folder. I'm going to call it database initializer. And all this file does, it has a single method. So inside this class, we have a single method called initialize, and it receives the context. So the first thing we do is to check if the database is not created, and this method that we called here actually creates it and returns true. And then we go ahead and create a list of dummy items. We add it to the list of items in our context, and then we call save changes to push those changes to the database. If the database actually exists, then this method returns false, and then we just return. So this is the database initializer class with the initialize method, and then the next question becomes, at what point do we initialize the database? In this case, we're going to do it once the app starts running. So for initialization like that, you do it in the startup.cs class at the root of the project. So at the top of this, I'm going to add 2 using statements for namespaces that we need. So we need entity framework for interacting with the database, and then we need the context classes inside the data namespace. These two. If you have IntelliSense, it should be really fast. Do you have the C# extension installed?
Yeah.
Okay. Alright, so I'm going to go ahead. So the configure services is where you initialize all the different services you need. ASP.NET Core is heavy on dependency injection. So if you just tell it whenever you needed a context class, use a specific class. It will create the necessary objects when it's time. We're going to add some more to that when we get into today's topic. But for now,
What's dependency injection?
it's out of the scope of what we're doing. But so normally, if you're creating a new object, say a car, for instance, a car has different parts: a door, car seat, the gear, and all the other stuff. You don't want to have to create each of those one after the other and then pass it to the constructor to create a car. You can just let it know that whenever you need an object of this class, use this method to create it and then supply it to whoever needs it. Well, like the name says, it injects your dependencies. So if something depends on another thing, it creates that dependency automatically for you. That's a dumbed down version, I guess. But it's not something we should worry about right now. All we're going to do here is specify that whenever we need a context class, it should use the context class that we created in the data folder. So to do that, it looks like this. So here we're specifying that whenever we need a database context, the associated class is appdb context, which is what we created in the data folder. And then the connection string is called default connection. So a connection string usually contains information about how to access a database and sometimes a password or username if necessary and where it's located. In our case, we're using a local SQLite database. So once we've added the method call for it to use the SQLite database, we're going to go to the configure method and add a parameter to the signature. So I'm going to add the appdb context to the signature of the configure method. Again, you don't have to worry about what calls this function. That's the whole purpose of dependency injection. It's going to supply all those parameters, and then we just need to worry about using it. So after adding that parameter up here, so I just added this
What's the name of the variable?
context. I added that to the configure method. And then at the very bottom, we need to use the class we created for initializing the database. So I'm going to say database initializer.initialize. And this method needs a context. So then you're going to say context. So what we're doing here is seeding the database. So once we're done setting this up, we now need to actually go create the connection string. So we've specified here that the connection string exists called default connection. To do that, you go to the app settings.json file at the root of the project. So there's an app settings.json file. I'm going to edit that and add a connection string. So it should look like this. So all this says is that the source for our database is catalog.db. So that's going to be a local file that's created automatically by Entity Framework when the database is initialized. Okay. So at this point, we've done most of what we did the last time besides the HTML related stuff. So we're not going to talk about the Razor engine for mixing C# and HTML to generate dynamic pages. We're going to focus on the API related parts of it. Again, so the connection string specifies where the database is. In this case, it's a file called catalog.db. It's going to generate that automatically. We modified the startup file to let it know to use a SQLite database on the startup and also to call the database initializer when the app starts. So if we want to test this, you can either use the command line, or if you want to do it through Visual Studio Code, if you click yes when that little prompt came up, you could just hit the play button at the top and that should build it and then start it. You don't have one?
the
If you didn't get a prompt, then it won't show up. There's a prompt that usually says required assets are missing, click yes to install. If you didn't get that, then the necessary configurations will not be there. You can just go to the command line and type .NET run. It'll build it and then start the server.
Gave me 2 errors.
What errors?
How do I look at them? Like, it just said 2 errors over there.
Could you, I guess, come over? Could you come close so I can come look at it? But in the meantime, if yours did build, you should, the color of the bar at the bottom should change to orange. And then eventually it's going to open up in the browser. You added stuff that we're not using yet. This is some of the stuff we're using today.
which one? Which
The
stuff?
item repository, click that one. And startup.cs. Scroll up. Remove that one. We're going to add that once we create it today. We're not doing that yet. We haven't done that yet.
Did I delete? Okay, that's it, right?
Yeah, try again. Okay, so if everything worked out, it should eventually open up in your browser. So none of the stuff we've done so far affects what you see on the website. This is just the default content that comes with it. You could delete this if you want to, but we're going to ignore it for now. The important thing that we want to see is that the database was actually created and it was seeded with the data. If you did this in through Visual Studio Code and you scroll up, you're going to see several database statements. So the very first one is to create the table. So this was all done automatically. Your properties and annotations are converted into SQL statements. So this is the statement that creates the items table, and then when database initializer was called, these commands were run to insert 5 items. So if you actually count this, you'd see that 5 items were inserted into the database. Another good thing about running it through Visual Studio Code, whenever you make a request on the browser, it actually shows the information about the request on the console, so you can look at it. Okay, so
I don't have anything on my debug console.
are you running in Visual Studio Code?
Close them.
Yeah, hit close Windows. And play them. Do it after the console. So for now, ignore using that. Just hit .NET run and command line. Yeah, so type .NET run and see if it works. It should work from there.
Well, why is it not working?
I'd have to look at the launch files. I can't do that right now. Yeah, but let me know if that works. It should, since it built. So if everyone is at this point, now we're going to go ahead and start the new stuff. So I'm going to stop it, and then we'll just look at the database to make sure everything is in there. So when you build the project and run it, you get a bin folder. If you open that, you'd see a file called catalog.db. I've installed a program called DB browser for SQLite. So we're going to use that to inspect this and see the contents, just to make sure that the stuff we created is actually inside it. Okay, so if you go over to the Browse Data tab, you'd notice we actually have 5 items inside our items table. So our database initializer is working. So before we can actually start implementing the API, we need to make some other sort of class to consolidate all the item related functions. So although we could directly modify the table through the context class, it's usually not a good thing to do, because that way different people could use different logic in different parts of the code. So looking at the API we had the last time, we need to be able to create items, update items, delete items, get a list of all items, and get specific items by their ID. So for that to happen, in the data folder, we're going to create an interface first of all, and then we're going to implement that interface. So for those of you that are not familiar with object-oriented programming, an interface specifies this. You can think about it like a contract. If an interface defines several methods and a class implements that interface, that means that class supplies all the necessary functions in the interface. Once we start writing it, it will make a little bit more sense. So in the data folder, I'm going to add a new file, and I'm going to call it iitemRepository.cs. So the I at the start is just a C# convention. You usually start your repositories with a capital I. So that's why this one is iitemRepository.cs. You don't have to follow the convention, but shame on you. Okay, so inside, again, the iitem repository is an interface. All it does is specify the different methods that we would like an item repository to have. So a repository is usually, you can think about it as a source of data. It's what you use. In this case, whenever we need to modify the item table or interact with it in any way, we're going to do it through a repository. So go ahead and type the following statements. To start with, we need items, and items are defined inside the models folder. So we have to add a using statement. And then the namespace is backend data. So this is how you define an interface in C#. We're going to add the contents in a bit. So again, we added the using statement at the top because we need items. We're going to use the item class in here, and since it's in a different namespace, you have to add that statement at the top. So notice before we use class because we were defining classes. Now we're defining interfaces. That's why this says interface. So to recap, we need to be able to get a specific item if we know its ID. That's one of the functions we need. So in here, we're going to type item get item, and we need to be able to do that given the ID of the item. So an interface just defines function. It doesn't mention how it should work. It just defines the functions that something should provide. So whenever we need to get a list of items, you're going to call the get item function. You give an ID and it returns the item. So these are the parameters. You give an ID and it's going to return an item. Notice that there's no member access. There's no public or private or anything on that function. So this returns a specific item, and then when we need to get a list of items, here we're going to use the enumerable interface. So if you type enumerable, well, to use this interface, we have to add another using statement. So at the top, I'm going to enter using system.collections.generic. So enumerable just represents a collection of items. It can be a list, a set, stack, something else. as long as it represents a list or some collection of items. So I added I enumerable, and I'm going to say item get items. So what this function does, it doesn't take any parameters. You just call it and it returns a list of all the items in a database. Now this is terrible practice in the real world because if you have several million items, it's going to return all of them at once. So you not normally do this. Ours is reasonably small, so we don't really care. So the first function returns a specific item given the ID. This function returns a list of all the items in our database. Yes. Yeah, single and plural. Get item, a specific item, and this one returns all the items. Does that make sense?
Yeah. Did we declare items somewhere?
We declared it inside the models folder. That's this.
Oh, okay.
That's why we had to add the using statement at the top. Okay, so this gets an item given its ID. This one returns a list of all the items. Something else we want to be able to do is to create items. When I say create an item, it means actually store it in a database. So I'm going to say item create. So given some item, this function is actually going to create it in the database and return the created item. And then I'll just add the others. So the last two of them are update and delete. So similarly, update takes an item, updates it in the database and returns the updated item. And to delete, all we need is the ID of the item. So this is what the interface looks like. It just specifies all the functions we need from an item repository. We're still going to go ahead and actually create the repository that does all these things, but usually have interface. So sometimes when testing, for instance, you don't want to actually have an actual database. You can just create a small one in memory. So that's one of the uses of interfaces. It facilitates testing, dependency injection. So these are this is the functionality we require of our items table. Is everyone okay with this? Okay. So this is the interface. Now we need to actually implement the interface. So I'm going to add another class inside the data folder. And this one I'm going to call it item repository. So this is where the first I is important. The one with item repository is an interface. And then item repository is an implementation of that interface. Some people add impl to the end of the class to indicate it's an implementation, but it's not normal C# convention, so I'm not doing that. Okay. So once you add this class, go ahead and add the using statement for items. So items are inside the backend.models folder. We'll add the others once we need them. And then as usual, the namespace right now is data, and then the class is item repository. Okay. So again, since this is object-oriented programming, we want to implement a specific interface. In Java, for instance, you use the implements keyword and then specify the name of the interface. In C#, you just put a colon and then type the name of the interface right there. And then the first thing you'll notice is that you get the red squiggly lines. So this class says that it implements that interface, but it doesn't actually have those functions inside it. That's why that line is there. So the next thing we need to do is actually provide each of those functions. So a quick way of doing that, if you click the light bulb on the left and select implement interface, make sure you don't select the first one. That's an entirely different thing. So we're going to implement interface, and it just adds the empty shell of all those different functions. And then it's up to us to actually provide the functionality in there. So the repository the interface specified the functions we need from an item repository. Now we're actually going to implement all those different functions. I guess just to make sure everyone is following. When you need to interact with the database, what class do you use? Yeah, I didn't say anything. So when you need to, I'll repeat the question. When you need to interact with the database, we created a specific class just for that. No. There's only a few classes we created. It's on the screen right now. The item class? No, the item class represents what we want to store in the database. So not that. By elimination, yes. Whenever you need to interact with the database, you use the context class. So to recap, inside the context class, we defined a single property called items. That corresponds to saying in our database we want a table called items. When we initialize the database, we also use the context class. We said context database ensure it's created. When we actually added items, we said context.items, and then we added all these items, and then we saved the changes to the database. So whenever you need to have any interaction with database, you do it through the context class. We're creating this repository. So I started by saying you could actually just use the context whenever you need to modify the database directly. But that's bad practice, because then you'd have different, if multiple people are working on the same project, for instance, you'd have different people using the context in different ways, in different files, to do the exact same thing, and that could cause problems in the long run. So we're using an interface to provide a streamlined access to items. Okay, so if we go back to the item repository class, if we need to interact with the database, we need a context. So somehow a context has to be in here somewhere. So that's the job of the constructor. So I'm going to add a constructor to this class, public. So constructor just has the same name as the class. And this is going to receive an appdb context. And we need to save it in a variable inside the class so we can use it later. So I'm adding a private variable. So private variables cannot be accessed outside the class. Public variables and functions can be accessed outside the class. That's just a primer and OOP if you're not familiar with that. Constructor is what creates new objects. So whenever we're creating this repository, we're going to give it a context, and then it's going to save that context inside a private variable like this. So all we do here is, when this is created, it receives the context, we save the context inside a private variable, and this is how we initialize this class. So we're going to implement the different functions in the order it was added to the file. So we're going to start with create, and then we'll go up to delete, and so on and so forth. Yes?
Hold on just a second.
Behind where?
I just needed to start with what you were.
You know I didn't type these manually, right?
Yeah, I
This-
remember that.
Okay.
I didn't have a little light bulb. I didn't know.
Did you get it eventually?
Yeah.
I'm guessing, are you just looking at it on GitHub?
Yeah.
Did you download it? Or just GitHub?
I'm copying and pasting.
Yeah, okay, that works too.
Okay, right.
Explain what context is.
I like to think about it as a gateway to the database. So
So whenever you create create an item repository, what context is you gonna pass in?
So this is where dependency injection comes in. So if you remember in the start of the CS file, we had a method services.add db context. and we specified AppDB context there. So whenever any component in our application needs a context, that dependency injection is going to supply it. Does that make a little bit sense? So
But where does it get the context from?
it will be created for you, is what I'm trying to say.
And so like it creates the context from the database.
The context represents the database.
Yeah, and the date. So it creates it itself.
Yes. So again, in starter.cs, inside the configure services, here we specified whenever we need a context, use this class. It's going to do, and then we supply default options. All this is saying is when you're creating the context, use this connection string. So this makes it automatically connect to the database and provide all the necessary functionality. So whenever an item repository is created, it's going to be given a context. We'll get to that part in a bit, but all we've done in here is to save the context inside a private variable so that we can use it in all the other methods inside this function. Are you having issues?
Yeah.
What?
It's not finding her item repository class.
Is it inside the same form?
Same before.
But mine is. Oh,
It's not finding it touches in there.
Madison, are you good now?
I'm good.
So the first thing we want to do is to actually, whenever we need to create a new item, we're going to see how that's going to work. Do you have the other lines? The private and the constructor. You need to make sure you have those. Okay. So the create function, it receives an item. So in this case, it's just an object. It's not in the database yet. We need to take that object, put it in the database, save, and return the item in the database. So what we're going to do here, we're going to say, so again, whenever you need to interact with the database, you use the context. We've stored it in a private variable. So we're going to use the context. The context has a list of items inside it, which represents the items table. So I'm going to say items, and this we added ourselves inside the AppDB context class. So mcontext.items dot. So there's different functions for adding stuff. In our case, we're adding just a single one. Now we're not going to talk about asynchronous programming right now. So we're going to use add. In the database initializer class, we had multiple items you wanted to add. So we use add range. And again, when you're not sure, IntelliSense shows you a brief description of what that thing does. So I'm using the add function, and I'm adding this new item. So if you modify the context and you want those changes you made to actually show up in the database, you have to call save changes. If you don't, then it's pretty much as if you didn't do anything in the first place. So we just added an item to the context, and then we're going to save the context, or save the changes to the context. So when you actually do this, the new item object is modified to reflect the new one it created in the database. So we're going to return it. just to recap, whenever you need to interact with your database, you use the context class. I'll probably give a quiz in the next one. And in the context class, we added a property to represent our items table. So mcontext.items represents our items table. We want to add a single item to that table. So we call the add function. Whenever you change or modify the context to make sure those changes show up in the actual database, you call save changes. And then finally, I return the new item that was created. So the rest of them are pretty similar. This is how you create an item. To delete an item, in this case, all we're given is an ID. So first of all, we need to make sure the item actually exists, that there is an item with that ID. So I'm going to add a function called getItem, and it's going to be, we have a getItem function. So we haven't implemented it yet, but the good thing about interfaces, we just assume whenever we need to get an item with an ID, you call the getItem function, and it gives you that item. So in here, I'm going to say, so C# it uses types unlike JavaScript, so you can actually say item, or it also allows you to do things like var item. It deduces the type of the object based on the thing on the right hand side. This is usually shorter when you have really long types. So I'm going to use item here. In subsequent methods, I'll use var, but just note the type of the thing on the right hand side is the type of the thing on the left hand side. Okay, so I'm declaring an item. I'm going to call it item equals, and I'm going to use the getItem function and give it the ID. So although we haven't implemented it yet, if an item doesn't exist, getItem should return null to indicate it doesn't exist. Or if you wanted to implement yours differently, you could throw an exception, but I think that's overkill, probably. So we try to get an item with this specific ID, and then we're going to check if it's not null. So if it's not null, that means an item with that ID actually existed. If it was null, then no such item existed. So I'm going to say if item is not null. And then when you need to interact with the database, you use the context. So mcontext.items, so this is our items table, and we're going to use the remove function. So remove removes a single item. If you wanted to remove a whole list of items, you'd use remove range. I'm removing the item that we found with that ID. And then to make sure that item is actually removed from the database, you need to make sure you call save changes. So the signature of this function indicates that it's supposed to return an item. So if we did delete an item, we're supposed to return it. If we didn't delete one, so if the item didn't exist, for instance, we return null. In either case, just returning null satisfies that. Sorry, returning item satisfies that. So if you did delete the item, item is the item that was deleted if it existed. If non-existent, item would be null, and you just return null. Is everyone okay with this so far? So we've shown how to create an item, how to delete an item. The next thing is how to actually get an item with a specific ID. So again, the context provides a find function. That function automatically uses, it takes a bunch of things, but if one of the things you specify happens to be the primary key, then it looks for things with that primary key. So here we're just going to say return mcontext.items.find. So there's several other ways you could do this. If you want to do in the database as the where statement. If you wanted to use that, you add link. We'll get to that in a bit. But we're going to use find here. So find, like it says, it finds an entity with the given primary key values. In our case, the ID of the item is the primary key. So we're just going to say find item ID. If it doesn't exist, it's going to return null. If it does exist, it will return the item with that ID. So get item is really simple. And then, so context.items represents, you can think about it as your items table. It's a collection of all your items. So if we want to get all the items in the database, we can just say return context.items. But just to be, I guess, not for safety purposes, we're going to present an actual list. So a list is a collection of items, so it is an enumerable. So if you call the toList function, so it's going to give you squiggly lines. We're going to add the necessary namespace in a bit. But for now, context.items.toList, capital T and capital L. So the toList function is provided in a namespace system.link. Link stands for language integrated query. It allows you to use normal C# statements to interact with different data providers, like a database and a file, an array, whatever collection you have, all with the same syntax. So if you click toList and hit the light bulb on the left, you can select using system.link, and that adds a using statement at the top for link, as well as, yeah. So you should have those 4 statements at the top for link, collections.generic, models, and system. So at this point, all that's left is for us to update an item, given the item to update. So this is the most, it's a little bit longer than the others. So if we need to update an item, we need to make sure it's actually in the database in the first place. So I'm going to remove that. I'm going to call it existing. So I'm using the var keyword here, but it's the same thing if you just typed item on the left hand side. And then we're going to use our get item function. So every item has an ID, title, description, and price. In this case, we're updating an entire item. So inside it, it should have the ID to allow us to find the existing one in the database. So we use that ID to get the existing one. And then if existing is not null, so we're trying to make sure, because if someone just made up some item, put a bunch of bogus information in there, for instance -1, and sent it to your API, we need to make sure it actually exists. So if get item returns null, then we don't want to actually do anything, so we'll just skip this. And at the bottom, we're going to return existing. So I'm going to put some code in here to make all the updates and then save it to the database. But what we have right now is saying to update an item, we need to find the existing item. If there's no such item, then just return existing, because existing is going to be null. So how do we actually update it? The things you can actually update are just the title, the price, and the description. So we're going to say existing dot title equals item dot title. So we're copying things from the object you gave us into the one in the database. And now we're going to say existing dot description equals item dot description, and existing dot price equals item dot price. So once we've done all this, we're not done yet. For your changes to show up in your database, you need to use the context and save those changes. So you need to let the database know, or you need to let the context know that you modified an item. So to do that, you use context.entry method. So the context has different entries. An entry is pretty much any object that you store in your database that the context is in control of. So I'm going to say existing, and then I'm changing the state. The state entity state.modified. Again, this will give you squiggly lines. You can use the bulb on the left hand side to add entity framework. So what this is saying, we need to let the context know that an item was modified. So here we're saying context.entry. So this entry's state has changed to modified. There's several other states. So for instance, added, deleted, attached, modified, unchanged. Normally if you haven't changed something, then it remains unchanged. But now we actually modified it. We let the context know by changing the state to modified, and then once we save the changes, it's going to create the necessary SQL commands, the necessary SQL update commands to update that specific item with the new changes. So we created a repository to give us a uniform or streamlined access to the items table. So whenever we need to do any of these operations, we just use the item repository class. We could do it directly with the contacts, but that would just have, we'll duplicate the same code in a whole bunch of places. This isolates it in in a single place. It makes it easier to test. So at this point, we have our repositories ready. We're going to go back over to, is everyone following so far? Are you following?
Me?
No,
Yes.
because she's shaking her head at it. I guess we don't need this one. We'll just leave it in there. Okay, so whenever we need a repository, we're going to use dependency injection again. So we're going to tell ASP.NET whenever anyone needs a repository, use this repository class. So if you go over to startup.cs, inside the configure services method. So before we go ahead, I need to explain one more thing. So whenever a user makes a request to your API, for instance, it goes through a whole pipeline of things you don't need to care about for now. And it eventually arrives at a controller. So we're going to create a controller in a little bit. But controllers have different functions in them that are called actions. So the controller needs the repository if it's going to actually, for instance, fetch items or delete items or do any of this operation. So we need to tell ASP.NET the dependency resolver that whenever we need an item repository and something that implements that interface, we need to use the item repository class. So to do that, we use services.add_transient. So for every request, so if you make a request to my API and someone else does, a new controller is created to service each of those requests. So that's why this is transient. It's created just for that request, and once the request is done, it's well, not garbage collected at that moment, but eventually. So we're adding transient Okay, so what this is saying is whenever we need something that implements the item repository, we need to use the item repository class. So that's what this line means. Again, for clean code, usually use interfaces. If you're given an interface, you just assume wherever you if you're given an object that implements an interface, you can assume safely that that thing provides the necessary functions you need. So here we're saying whenever we need something that implements the item repository interface, use or create an object of type item repository. And to create an item of type item repository, it in turn needs a context. We already added a similar line here saying whenever we need a context, create an object of this class. So it takes care of all of that object creation for us. So at this point, we're done with startup.cs. And we're also done with our repository class. So what's left is for us to actually implement the API. So when a user goes to ////API/get, for instance, we need to have a corresponding function in here that receives that request, processes it, and returns something to the user. So if you go to the controllers folder, so this is not convention, but it's something I like to do. MVC model view controller, you can use that for, well, before ASP.NET Core, you had ASP.NET MVC and API. So I like to separate my controllers. So I know this is for normal requests, for instance, to return a web page, and this controller is for API requests. So I'm going to create two folders inside the controllers folder. Call the first one MVC with a capital M. And the second folder, and I'm going to call that one API with a capital A. So by default, you should have a controller, home controller, that's added for you by default. It has a bunch of default stuff. Move that file into the MVC folder. So I moved home controller into MVC. This is just so I can have a clear separation. If a specific team, for instance, needs to work on all the APIs, they work on a specific folder. If a different team is working on what the user sees, they work on a different folder. Okay. So once we have that, what we're doing right now is implementing the API. So in the API folder, we're going to add a new file, and I'm going to call it item API controller. So I'm adding a new file to API called item API controller. Again, the API in there is just to make it obvious that this controller is just for APIs. You can have another one, item controller. For instance, if you wanted to return web pages related to items, for instance, a table of items, or to update items on a browser. So .cs, don't forget the C# extension. So I mentioned controllers have functions in them called actions. In our case, we want, going back to the HTTP verbs we covered earlier, we want get, put. So get returns a list of items or a specific item, depending on how it's called. Put is usually used for updating items. You use post to create new items, and then you use the delete when you want to delete items. So inside this class, I'm going to add using statements for our models and our data folder. So using backend.data, using backend.models, and then using, we'll get to that part in a bit. So the data folder, we added that here because we're going to, when a request comes in to get a list of items, for instance, we use the repository to get that list of items. So that's why we had to add the backend.data. The item repository is inside the data folder. The item class is inside the models. So if the user wanted just one item, for instance, that's why we have the models folder. So go ahead and add the namespace. So I'm going to call this controllers.api to make it explicit. This controller is just for APIs. So the class we're creating, we're going to call it, so we're naming it, we're giving it the same name as the file, item controller. Public class that. So just creating a class and ending it with controller is not enough for ASP.NET to know that it's actually a controller. You need to extend an existing class provided for you by ASP.NET. So this class is going to inherit from another class. So an OOP inheritance allows one class to have all the functionality of another class and provide some extra stuff on top of it. So I'm going to inherit from the controller class, not plural. And as always, you get the squiggly lines and then use the light bulb to add a reference to ASP.core.mvc. So this is our controller. We need to add different methods to it. For instance, when a user wants to get one item or get a list of items or so on and so forth. I don't have the PowerPoint open, but if you remember the API I showed you from the last time, it's also in the PDF document on the Facebook group. So to interact with the items table, we created the item repository just for that. So instead of using the context here directly, we're going to use the item repository. So we're going to use the interface. I'm going to add item repository and call it mrepo to make it short. So I've added a private variable. And just like in the repository class, it was initialized with the context. So here as well, we're going to initialize this. So we're going to add a constructor, item API controller, and it should receive an item repository, and then call this repository. So if you remember, in the startup.cs file, we said we added a method called add transient. The first thing was item repository, and the second thing was item repository. That was pretty much saying whenever we need something of the type of that interface, it should create a new object of that item repository. So ASP.NET is going to create it automatically for you whenever a request is received. It creates the controller automatically with the right parameters. So here we're just going to save it in a private variable like we did in item repository. So I'm going to do this. So we'll start from the easiest methods, just like we did when implementing the repository. So the first one we're going to add, I guess before we go on, ASP.NET is heavy on conventions. So it means if you make a method in here and you call it get, whenever a request comes in, whenever a get request comes in, it's going to use that method. You can give them different names, but then you have to add an attribute to let it know that you used a different name. So what that means is we're going to add a function, and the return type is action result. You should remember this from the last time when we were playing around with HTML files, but if you don't, that's fine. So I'm adding a function or a method called get. And just to be sure, to be explicit, we're going to add an attribute to this, a HTTP get attribute. So attributes usually provide some information. I don't remember what it's called, but ASP.NET looks at all different classes. Yeah, it inspects the code, sees what attributes is applied to what, and that's how it knows what to use at what time. Just like in our item class, we had a required key, max length, min length, and all that stuff. So attributes usually describe some property of something. So in this case, we're specifying that when a HTTP get comes in, we need to use this function. And I also like to put comments here, so if someone is reading this, they know exactly how to call this method. So this is a get the API / items. And we're missing something, but I'll get to that in a bit. So then the question is, what does this function actually do? It needs to return a list of all the items. So that API in the table we had before was supposed to return a list of items. So to get a list of items, you use your repository. So I'm going to say mrepo. You can say this. But then we get squiggly lines. So far everything we've done has been in JSON, because it's a nice format to represent information. So we can't just return get items like this, but the controller class provides a function that we can use to convert arbitrary objects to JSON. So if you just add JSON before that call, so this process is called serialization. It takes an object, serializes it to a JSON string, and returns that object. So this is the API. Whenever a user makes a request /API/items, it goes through a whole bunch of pipelines. Since we called, okay, we're going to add one more thing and then I can explain. Does everyone have this so far? Okay. So in the just before the class, so you can add attributes to methods. You can also add attributes to classes. I'm going to add an attribute to this one to specify the route we want to use. So far I've been saying /API/item. The next question is, how does it actually know that it's /API/item? To do that, use a route attribute. So what this is saying is, whenever the server receives a request to anything starting with /API/items, is going to give that request to this controller. And then inside here, if the request was a get request, then it's going to call this function. And all this function, that's it. all this function does is to return the list of items and converts it to the JSON format that we've been working with. Everyone good so far? Ask questions. Is anything confusing? Okay, so the API we described, it's the URL, so www.fancycatalog.com/API/items. The ending part of it is /API/items. The question becomes how does ESP.NET know to use this controller for that URL? You use that route at the top to specify that. So yeah, when it sees that, when it inspects the file and sees that attribute, it pretty much decides whenever I get any request to this API, create this controller to service that request. And now, if that request was a GET request, for instance, it's going to call the GET function because we put the HTTP GET attribute on top of that method. So it looks at the URL, decides which controller, and then it looks at the HTTP verb to decide which, in this case, which method inside the controller. And the methods are also called actions. Okay. So this returned a list of all the items. The second API we had was to return a specific item with a specific ID. So we're going to add something very similar to what we have right now. It's also a HTTP GET. But this one has a little bit extra in it because it needs to have, okay, before we go on, let's add the method and then we'll add the attributes. So this method receives an ID and it needs to return a specific item with that ID. So just like we did before, there's going to be JSON, and then to get an item with a specific ID, use your repository. So mrepo.getItem, and you give it the ID that you were given. So when the user goes to this URL, for instance, get/API/items/1. 1 is the ID. So ASP.NET is going to take it from the URL and give it to this function. And then you use your repository to get an item with that ID and you return it as JSON. So even if it's null, it'll return the appropriate object for you. So now, just like we used the HTTP GET attribute on the previous, we're also going to do something similar here. We're going to say HTTP GET. So right now, it's actually going to be confused because it won't know which of these to call. Both of them are GETs. So to clarify, we're going to specify if it has an ID in it in the GET request, then you're going to call this function. Otherwise, it will call the default one at the top. But this is something. Do you have a question?
Yeah, so once you get a GET request, it's gonna do whatever, like the one
That matches.
function that's under HTTP GET?
Yeah, so if we didn't add the ID in braces thing, it'd give you an error because it wouldn't know which of those two functions. They're just HTTP GETs. It wouldn't know which of those. So here all we're doing is specifying that this particular HTTP GET also comes with an ID parameter at the end. So something I didn't talk about, routes. If you look in the startup.cs file, we defined routes here. So it's usually, for instance, the name of the controller, the name of the action, and then an ID. The question mark means the ID is optional. So if you go to the browser, for instance, you type localhost :5000/home/index. That takes you to the home page. And if you look inside that controller, so the name of the controller is home controller. So that's how it knows to use this controller. It uses that convention, and this has an index method. So in this case, we didn't need. So this is not for APIs. This is just for normal MVC stuff. So it uses the names of the functions to figure out what controller to create and what method to call. For these, we have to specify it's for HTTP API requests. So by specifying ID here, it knows it can tell this apart from this one. If there's no ID, it uses this one. This is saying use this only when it has an extra ID at the end. Yeah, that's why it's also a good thing usually to put a comment up there to see what it should look like. Everyone good? Okay, and then the last 3 of them. So when we need to create items, we need to do a post request to API/items. But in this case, the body of the request is going to be the JSON object. If you remember what we've been doing with Postman and AngularJS. So your request will be to API/items, but it will be a post request. And ASP.NET automatically knows to look inside the body of the request and try to figure out where the item is. So this is going to be a HTTP post. So I'll explain what this means in a bit. So I don't remember what it's called, but whenever ASP.NET receives a request, there's several places it can look for stuff. So I don't know if you're familiar with URLs that look like this. So on Google, for instance, you might see google.com !q equals some jargon like that, for instance. So those are query strings. You can have, so for instance, this is a terrible example, but let's say you had a car service and you wanted people to be able to find different cars by make, year, so on and so forth. One way you could do this is allow them to specify it using the query string. So something like year equals 1994, make equals Toyota, so on and so forth. This is one way, using query strings. So this is called a query string. That's in the URL. The user could also supply it as a JSON object in the request, like we've been doing with Postman. You make an object and say, so in JSON it might have looked like this. Some object, and you'd say, yeah, finding. Yes. So there's different ways you could supply the necessary information. There's the query string, there's a request body, there's several other places it looks for. But here I'm being explicit. We want it to look at the body of the request. That's what that attribute does, the from body attribute. It forces it to look in a specific place, and if it's not there, then it returns an error. Okay. So at this point, this is where we use the attributes we put on the item class. ASP.NET provides model validation for you automatically. So after parsing the item, or in this case, after deserializing it from the body, you need to make sure it's actually valid. So by valid, that means it needs to have a price, title, description, because of the required attributes we put on them, and the description and the title need to have minimum of 1 and a maximum of either 100 or 300 characters. So that's what model validation does for you, to check that it's that model validation succeeded. This is what you do. So it has a model state. Whenever it's deserialized your item. So again, item can be from a bunch of places. In this case, we said it must be from the body of the request. And once it gets it from there, it also notes down some stuff. For instance, if it was a valid item. So what we're saying here is if the model was not valid. This is going back to model view controller. In this case, our model is item. The view would be the JSON we return. That's a specific representation of the model. And then this is the controller in between. Make a little bit sense? Okay. So here we're trying to make sure if the thing we got is not valid, then we're going to return a bad request. Yeah, so in terms of HTTP status codes, that's a 400. Now we might look up some more. But yeah, so all we've done right now is said if the thing we received was not a valid item, then return a bad request. Otherwise, then we need to actually use the repository to create that item. So we're going to say mrepo.create, then we give it the item, and we need to return that item as JSON. And this is a post.
It should be called like I action result, right?
Either would have worked, but
Either way.
yes. Because action result implements the I action result interface.
Oh,
Just like item repository implements I item repository.
so since it uses the same stuff, it doesn't matter.
Yeah, both of them. Action result provides all the necessary functions specified by I action result. Okay. So this is how you do a post, and then we'll do put and delete. They're almost the same thing. I'm going to go ahead and copy this one and paste it and just modify the attributes. So copy the post, paste it, change it to put. I'm going to change this as well to put the name to put. And instead of creating an item, we need to update an item. So post and put are pretty much identical, or just different names. I changed HTTP post to put. I changed the action name from post to put. And then instead of repository.create, I'm using repository.update. And then we return the result as JSON. Good. You ready? Oh, I'll wait. Okay, so the last one we need to do is delete. So delete also needs to receive a specific ID. So it's going to look similar to how we did the get with an ID. So this is API/item/1, for instance. That's what it should look like. So we have to specify HTTP delete, and we should expect an ID in there. So whenever you make a request, for instance, and it doesn't match any of these, it just returns an error to you because your API does not provide that method, for instance. So all this API provides is get, put, delete. There's a whole bunch of other ones, patch, list, a bunch of them. This is all ours provides. If you make a request using one of those other verbs and it can't match it to any of these functions, it will return a bad request, so some sort of error.
And it just does that. That's automatic. Or
Yes. ASP.NET provides all that for you. Okay, so similarly, we're doing delete. We're given an ID. And all we do in here, if you remember, the repository.delete returns the item that was deleted. So you give an ID and it returns the item that was deleted. If the item was not there, so for instance, if no such item existed or if it was already deleted before, deleted item is going to be null. For this API, I'm going to return not found. So that's a 404. I almost forgot like the most important HTTP word. Okay, so what we're doing here is we're saying if deleted item is null, that means no such item existed. So that means you're trying to delete something that wasn't there. So if you remember, delete, make sure the item is there. If it is, it deletes it and then returns the item. If it wasn't there, it just returns null. So what we're doing, we're checking if it's null, that means it wasn't there. In this case, we return not found. So not found, bad request, JSON, those are methods this provides for you. You can actually, if you wanted to use one of the other status codes, So for instance, right here, 210. I don't know what that stands for, but you could make a status code result object yourself. I'm just showing this. We're not actually using it, but just to show you that you could return all the status codes, and then you just give it the number. So for instance, 201, and that returns the status code with the message. Status code of 201. I think 200 is okay. I don't remember. Okay, but this is not what we actually want to do. So if the item wasn't there, we return not found. If it was there, then we just return the item as JSON. And then our API is pretty much ready to go. So we introduced a bunch of stuff. We talked about dependency injection a tiny bit. Went more over the context. We created the repository to simplify access to items. So instead of having, when starting out, for instance, you could use the context here directly and write all the same things we had inside the repository, inside each of these functions. But if you wanted to use that same functionality somewhere else, for instance, you'd have to write the exact same code. And then when it's time to make changes, you have to go fish for where did you have this and change all of them. By using a repository, once you change it in one place, everything that uses the repository is updated at once. So that's why we usually have repositories. There's other patterns, but this is one of the ones we're using for now. So once you have all this, I'm going to go ahead and save, close them, and then I'm going to start the server again. So if you're using the console, just go ahead and do .NET run. I'm going to use Visual Studio Code directly.
No, I have to put in .NET Run.
Yes. I clicked it, right? I think I clicked it. Okay, I did. I'm going to use Postman just to show that it works, but we'll do that really quickly, and then we'll be done. And then the current plan for next week is for real-time messaging using PubNub. I'll try to think of some interesting example. And then after that, we're going to use Selenium WebDriver for web automation. Okay. So it built correctly, and then it's going to start running. And then I'm going to open Postman in the meantime. So this time, it's not going to have the same SQL code commands we had the last time. That's because the database already exists. So it's going to skip that part. Okay. So now it launches it in the browser. If you actually just wanted a quick test of the API, you could do it without Postman. So once this loads, we'll go ahead and test it. So I'm going to move this over just to show you what it actually does with all the requests it receives. So in the browser, I'm going to go ahead and type /API/items. And if you pay attention to the output on the right hand side. So once you hit enter, a bunch of stuff happens, but the important thing is we did get a list of items as JSON on the left hand side. So now we're going to look at the output and see what happened. So at this point, it received your request. So it received a GET request for localhost API/items. And then it figured out what controller to invoke using the controller invoker. So it automatically figures out that it should use the item API controller. And then it needs to figure out which action to create. So in this case, it decided to use the get action, and the model state was valid because there was nothing to validate in that case. And then we use our repository. So when you use the repository, it generates the necessary, the repository uses the context to get the items from the database. So that automatically generates the necessary SQL code, which in this case looks like this. We're selecting from the items table. Blah, blah, blah. I should be aware there somewhere. Yeah, but it generates the necessary SQL code, returns it. Yeah, sorry, that's selecting all the items, so we don't need the where. So it just selects all items from the items table and returns it as JSON. So it uses, it's Newtonsoft, that's what it uses, but it uses a specific library to convert that list of objects to JSON result, and it returns that to you in the browser. So at this point, the request is finished. So for every request you make, this is what the pipeline looks like. The web server receives the request, figures out which controller to call or to create. In that controller, it figures out which method to call. In this case, methods are also called actions. And then whatever code you put there runs, and then it returns something to the user. If we go back over to Postman, we'll do a post request quickly. So currently we have five items in the database. I'm going to create a new one using a post. So it expects JSON, so I'm going to have to set the type to raw and change this to JSON. So I'm going over this part quickly because we did it the last time. And each item looks, so when you're creating a new item, you don't need to care about the ID. The ID will be assigned in the database and returned to you. So here, all you need to specify are the other required things. So it needs a title, this, we need quotes around those.
Double quote.
Oh, I'm tired. Thanks. That would have probably taken me some time. Okay. And then the description. You don't have to type one time. And then the price. So this is the body of our request. If you remember, if you look at the controller, we're doing a post, and that looks like this. It's going to get the item from the body of the request, and it's going to make sure that it's valid. So let's put, I'm going to put a breakpoint there so we see what actually happens. I haven't tested this with ASP.NET Core, but hopefully it works. I'm going to skip the price just to make sure it's actually not valid. So from what we said, title, price, and description are required. So now I'm going to do a post. Sorry. I'm going to send the request. So we eventually end up at that line in there. Takes a bit when it's debugging.
You have no from JSON.
I do.
You have a comment at the end of
Well, let's see what happened here. Okay, so I'm going to step over, go line by line. We'll keep going and see. So I haven't verified this ASP.NET Core before, but in the normal ASP.NET, you should get an exception at this point because it's missing a price. Let's see what result is. So they gave it a default price of 0, so something didn't work somewhere in there. But this is pretty much how this works. You make a post request, it parses the JSON you gave it, creates an item out of it. We use our repository to create the item, and then we return it to the browser. So now I'm going to hit this. And if we go back here, we have the new item that we just created as JSON, and it's all stored in the database. So I'm going to open that quickly so you can see everything we're doing is there.
price wasn't required in the model.
It wasn't? Ah, my bad. Okay, so let's test something else that was required. But it was correctly created. So let's test something else just to make sure that the validation is working. I'm going to do another post. Remove the ID. Oh, let's remove the description and see what happens. So we're not debugging this time. We'll see if it creates it successfully or not. Okay, so we did get a bad request. So in our model,
Where did you put that request?
at the bottom of the page, if you look at so the top is for the request, the bottom is for the response. If you look at this, we got a bad request. And looking at our code, so item says the title and description are required, but price is required.
No, mine doesn't.
I'm guessing since it's an integer, defaulted to 0. Okay, but for other, I think for objects, it actually verifies that they are there. So in this,
2 weeks ago, price wasn't required.
so yes, in this case we didn't supply the description, and the validation rules that we put up there actually kicked into effect. And what we had here was that if it wasn't valid, it should return a bad request. So that's why we got a bad request here. And then, question?
You wouldn't have put required on there, it would have just posted it.
Yes, and then that thing would be just null, an empty string. Right, so this is pretty much how APIs work. You can do something more complex. You can have, well, in this example, we just had a single item. It would have been a little more difficult to show different items, like aggregation when one item has a list of other items associated with it and things like that, but we don't have time. So we're going to go ahead and stop here. In the next class, we switch back to regular JavaScript. Hopefully, some of you will consider using ASP.NET. Okay, that's that for